Hey, you guys. This week, as you go forward, you are going to be working with inequalities. We started looking at inequalities a little bit last week. So this time they're going to give you guys some word problems, and you're going to have to figure out which inequality, whether it's less than, greater than, less than and equal to, or greater than and equal to, or equal to, symbols that you would use. So let's look at a few of those problems. Now, the first thing I want to point out is the phrase less than. Over the years as a math teacher, when I've had students that should have used an inequality, they would use a subtraction sign and vice versa. So first of all, knowing what kind of lessons that you're in, like what are you guys doing? Are you subtracting or using inequalities? So that'll be your first hint. They wouldn't be using inequalities and then in the center of that throw in a subtraction problem. So always think about what type of lesson you're doing, what kind of example, other problems that you're answering. But there is a slight difference in when to use a subtraction symbol and when to use the less than symbol. So if I said 7 less than 10, so let's say my friend had 10 M&Ms and I had 7 less than that number. Well, that means I'm going to subtract. 7 less than 10 means 10 minus 7, which of course the answer is 3. But when you see that word is, this is a very slight difference. 7 is less than 10. That is a statement. 7 is less than 10, which of course it is. 7 is less than 10. So that's the difference in when you use subtraction and when you use an inequality. So just kind of remember that as you move forward in your math lives. All right, but anyway, when will we use these symbols? So let's say you're going to the mall with your friend and you said, Mom, I want at least $20, please. Well, what does that mean? Do you want $15? No. Do you want $20? I mean, you'll take it, but you really want more than $20, right? So if you say, I want at least $20, that means the amount of money I want is $20 or more. So the amount of money I want is greater than or equal to 20. So my unknown variable would be X. How much money is Mom going to give me? Hopefully that amount of money is going to be greater than or equal to 20. What else? I can buy no more than 7 pizzas. You're having a bunch of friends over and you're saying, Mom, we're going to be hungry. We need lots of food. And your mom says, I can buy no more than 7 pizzas. What does that mean? How many pizzas is she going to buy? That means she's going to buy 7 at the most, right? 7 or less. How many pizzas can I buy? 7 pizzas or less. The amount of pizzas has to be less than or equal to 7. If we don't know how many pizzas that is, we would have a variable. P is less than or equal to 7. All right, what about the school? If we're going to have a dance, we might say in order to have a dance, we have to know that more than 200 people can come. That doesn't mean we can have a dance if 200 people come, right? We have to have at least, or we have to have 201 or more. So the amount of people has to be greater than 200. So if P represents the number of people, P is greater than 200. The train can hold no more than 275 people. Does that mean that the train can hold 275 people? Yes. Can it hold more than 275 people? Nope. So the number of people in the train has to be less than or equal to 275. In order to vote in an election, so we just had an election, were you allowed to vote in it? No, because you were not 18 years old or older. So to be at least 18, that means your age, if that's X, must be greater than or equal to 18. So the next election, let's see, you guys are what? Probably not the next election. You guys are 12, 13? So 13 plus 4, 17. Oh, a couple of you might be able to vote, but not all of you. All right, so now we're going to talk about how to graph inequalities. So I have a great big number line I'm going to use, but I gave you guys little ones in case hopefully you're trying these problems with me. I'd love for you to try the problems first. Pause my video, try the problems, and then come back and see if you get the right answers. All right, but X, that means a number, an unknown number is greater than 4. So how many solutions could make that statement true? Well, I know that 5 is greater than 4. What about 6? Is 6 greater than 4? Yep. What about 2 million? Is 200 greater than 4? So there's an infinite number of solutions. So basically, it doesn't say that X is equal to 4, but 4 is my starting place. So I'm going to come to 4 and I'm going to put a little circle right there. And I'm going to leave it open. I'm not going to fill it in because X is not equal to 4, but X can be any number right of 4. My little pen is not going to let me put a circle. It just doesn't like that. There it goes. So X can be any number to the right of 4 on a number line, but it doesn't include 4. All right, let's look at the next one. X, an unknown number, is greater than or equal to 0. So does that mean that X can be 0? Yep. So I'm going to fill in my circle if this pen will let me. And then X could be 1 or 2 or 3 or 4 or any number to the right of 0 on a number line. So this time my circle, if my pen will let me write a circle, is filled in. This one's open. See, number 1, it's open. It doesn't include 4. Number 2 includes 0 because it says or equal to. Number 3, X, an unknown number, is less than 7. Well, what numbers are less than 7? 6, 5, 4, 3, and then all these negative numbers to negative infinity. So can X be 7? No, but that's our starting place. So I'm going to leave it open. And then X could be any number on a number line to the left of 7. Number 4, X is greater than or equal to -1. So I'm going to find -1. Can X be $-1? Yep. I'm going to fill in my circle. And then which way does my arrow go? Well, if you guys look at these up here, now look at this sign right here. It kind of looks like the top of an arrow, right? So if I make that into an arrow, it looks like, oh, I have an arrow pointing to the right. Well, that's what's happening right here, right? Look at number 3. If I made this an arrow, wouldn't it be pointing to the left? Whoops. Oh, no. So number 3, my arrow is pointing to the left. Well, so does my inequality after I graph it. So guys, here's the trick. As long as your variable comes first, and it does on every one of these problems, then your inequality sign will look like your arrow and vice versa. Oh my goodness, my pen is giving me fits today. All right, so as long as your variable comes first, your arrow and your inequality sign look the same. So number 4, which way?
Please complete your daily rounding and send the first load of car riders to the front.
So number 4, which way would my arrow be pointing? To the right. And this time I filled in that circle because it includes -1. Number 5, X is less than or equal to 3. So I'm going to fill in my circle. It's going to be a closed circle, and my line is going to be pointing to the left. Number 6, oh, my circle went away. Number 6, X is less than 0. That means that X can be any negative number because all negative numbers are less than 0. I didn't fill in that circle though because it doesn't have that or equal to sign under it. That part is missing. Number 7, X is greater than or equal to -4. So I'm going to fill in my circle and my arrow is going to point to the right. All right. So that's how those look. All right, the least value a variable can be is 12.
May I have your attention, please? Any
Sorry, guys.
7th or 8th grade girl interested in trying out for basketball? Tryouts will begin next Monday, November the 9th, after car riders are dismissed.
All right, so number 8.
You must have your current physical on file in order to try out, and your ride will need to pick you up at the bus ramp at 5 o'clock.
Number 8, we need a variable. So I'm going to use an X. It doesn't matter, whatever variable you want. And we're going to use a 12. So if this variable can be the least value, it can be as 12. The least value, can it be 12? Yes. Can it be 11? Nope. Can it be 13? Yes. So our unknown variable has to be greater than or equal to 12. So some of these seem confusing, but if you'll just kind of talk your way through them, you can figure out what they're looking for. Okay, the least value of variable could be the least amount this x can be is 12. That means it can be 12 or a number greater than 12. Number 9, there are currently 4 people signed up to play on the baseball team. The team must have at least 9 players. What does at least mean? 9 or more. Graph the possible values of the people who still need to sign up for the team. So we already have 4. If we need at least 9, how many people do we need to sign up? What do you think? What if 5 people signed up? Would that be enough? Yep. So the number of people signing up can be 5, because 5 and 4 is 9, and that's at least 9. Or what? What else? Can 4 people sign up? Nope. But a number greater than 9. So 5, 6, 7, 8, all the way up to infinity, even though that would be a very large basketball team. Oh, my thing went off. But anyway, I was done. Anyway. All right, you guys, so I hope that helps you out. If you need any more assistance from me, then send me a message and I'll get back to you. Have a good day.